The next report will be made by Ms. Marina Moiseeva from GIA Innoter, Russia.
Добрый день. Сегодня я
Hello, I will try to share with you our 3D modeling projects that we created at Innoter. 3D modeling as a new way of representing data has recently been picking up a lot of speed and getting more and more popular, finding applications in an ever-increasing range of human activities. The value of 3D modeling is that it allows to depict in 3D not only the existing but proposed objects as well. I will try to dwell upon those 3D modeling objects that are most in demand these days. One of the key areas is information support of design decisions. The application of 3D models allows to test decisions during the engineering design stage, which reduces cost and improves the quality of design. Modeling or simulation is implemented in two stages. The first stage can be called the preparation. This is initial stage, and it's the same set of functions as for 2D design, but there is an important element added to it which is missing in 2D modeling. That is aerial photography or remote sensing data captured from space. And the next stage is analytical and calculations stage. That is determining the flood areas, etc. A peculiarity of a task is in modeling and optimization of decisions to be executed. The most important here is assurance of control of technical decisions at this stage, because it allows to reduce greatly the number of design errors without increase in noticeable mistakes on the existing site. A virtual 3D model allows for visual control and optimization given the terrain and the available infrastructure. 3D projects combined with 3D model of the territory gives you an idea of how proposed elements will fit into the existing landscape. Today, 3D modeling is applied in object monitoring and management fields. Monitoring can be subdivided into routine monitoring, the one conducted at a regular interval, online monitoring, when the info is available at any given time, and temporal monitoring. We're talking about in longer intervals. Besides, the results of monitoring can be presented in 3D model showing the dynamics of change. Real-time monitoring is an interactive management system for spatial processes based on 3D modeling of objects. In other words, management of the functioning of objects, which includes feedback, that is information, feedback-driven monitoring. The graphic representation of management elements included in 3D model allows to perceive information in the most convenient and natural fashion, which favorably reflects on the quality of decision-making process. Now I'll try to be more specific and share some projects that we did. The first project is a 3D model of Angola territory. This is an example of modeling of agricultural farms in the framework of European Bank of Reconstruction and Development. International Bank of Reconstruction and Development. The main purpose here was to create a topographic map and 3D model of the terrain over the agricultural land. During the project, we did the following. We planned space image data from GOI with 5-meter resolution, photogrammetric processing, orthophoto, and creating digital photo map and digital map. The next project is designing customs terminals for railroad station, Russian railroads. Russian railroads have a program calling for the creation of about a dozen terminals across the country. A 3D model was created for the territory of the village Belый Rast in Moscow region to design one of such bonded terminals. What was the objective here? That is to build a 3D model of the terminal based on the project documentation, building a digital terrain model based on remote sensing data, and choosing the best location for the terminal. The use of this system allows users to carry out measurement operations in 3D dimension and to compare them from various angles, simulate movement of vehicles and rolling stock, and to do other tasks. This is the model itself. The application of 3D modeling. The next example is the application of 3D modeling as information support for decision-making in telecommunications network in the city of Bucharest. It is impossible to do it without analytical calculations based on 3D modeling of areas. A simplified version of Bucharest was used to locate broadcasting stations. It's impossible to change spatial characteristics of one element without affecting the characteristics of other elements. And the last example I have is a 3D model for Vnukovo airport. Every year, the administration of the airport requests space data acquisition in order to monitor the progress of construction of various airport-related infrastructure. We built a simpler model of the airport road and railroad and the adjacent territory with the total area of around 100 square kilometers. Visualization of changes in the terrain based on 3D model and possibility to monitor the movement of aircraft and ground vehicles. Modern technology allows to create 3D models for railroads, roads, transport infrastructure, power lines, and energy infrastructure. The use of 3D modeling can provide better quality, and the level of detail depends on the task at hand. We believe there is no doubt that 3D modeling becomes crucial, a part and parcel of any management system needed to address a wide range of practical tasks. Thank you, that's all I have. Thank you very much. Are there any questions? Can you please tell me which software did you use for 3D modeling? I saw some buildings, and you must have had some customers. The projects that I showed were mostly pilot projects, so we didn't aim to get the best accuracy possible. We used MicroStation as software, but for the next presentation I think we will try to use PhotoMod. But did you deliver anything to the customers? No, it was a pilot project for demonstration purposes only. You showed a 3D model of Bucharest. Who did this? You did it? Our people did? Based on what image data? As I said, it's a simplified version. I think we used Iconos imagery. For the whole of the city? No, just individual sections of the city. Thanks a lot.